Today I am going to discuss equation of kinematics. Now this equation has been taken from the chapter motion. There are three equations: v equal u plus at, s equal ut plus half at square, and v square equal u square plus 2as. These three equations are known as equation of kinematics. Okay. Basically, now you have to understand the meaning of these symbols v, u, at. So let me clarify. For example, there is a particle, any body of mass m, moving with velocity u. So this velocity is called initial velocity. This body attains velocity v at this point. For example, body moves from P to Q. So this velocity v at point P after time t is called final velocity. Initial velocity at which the body is moving, and v is the final velocity at a point Q the body attains. Okay, there is a change in velocity. So change in velocity, it means there is acceleration in it. Okay, which acceleration represents as delta v over delta t, acceleration. And there is a displacement also from P to Q. The displacement is shown by the symbol S. So these are the symbols, and these symbols can be used to write these equations, which are known as equation of kinematics. Basically, these equations represent uniformly accelerated motion. There is an acceleration which is uniformly accelerated. Okay, so we can prove these equations by using graphical method. By graphical method, so firstly we have to draw a velocity time graph. For example, we take a xy plane, that is our origin. Okay, now we take at a particular instant there is a velocity u initially. On x-axis we take time, and on y-axis we take velocity. Okay, so at a particular instant velocity u, after time t velocity changes by v. Okay, so now by this graph we have some region over here. There are two regions. Number one, there is a triangle. Now we shade for you, and there is a rectangle, and we can put also some general symbols A, B, C. Okay, and that is D, for example. So there are two regions here, one is triangle, other one is rectangle. So now this particular side represents U, means AB, and here BC will represent V minus U. Okay, and this total side represent V. So we can write also, we can assume let OA equal BD equal T, and we can also write BC equal V minus U, and AB equal U. Okay, and AC is present. We can take from this diagram. Okay, so firstly we will approach for equation number 1. For equation number 1, we have to prove this v equal u plus at. So from the definition of acceleration, we know that rate of change in velocity is called acceleration. So now this side BC means v minus a represents change in velocity. When we measure this change with respect to time, that is called acceleration. Means we can write acceleration as BC, this change, over, we can write the change in velocity with respect to time. Time is basically like this side, BT. So V minus U over T. You can take AT equal V minus U, and you can write V equal U plus AT. This is your equation number 1. Now we approach for equation number 2. for equation 2. For equation number 2, we take the area of these two regions. In this particular graph, there are some shaded region which represents the particular area of these two particular regions, and this area represents displacement. For example, if we measure this area of this rectangle, so now area will be AB into OA. AB represents U, OA represents T. So U into T means velocity into time will displacement. So same way, so we can write displacement here is area of triangle of BDC, and plus area of rectangle here is OABD. So we can write area of triangle means half base into height. Half base means BD represent base, and into height means BC, plus area of this length into breadth OA into AB. Okay, now we put the values. BD here is T, and BC here is V minus U, plus OA T and AB represents U. Okay, now we can also put the value of V minus U from equation number 1. From equation number 1, V minus U will be equal to AT. So that's why half into T into AT plus here is UT. So this equation can be written as S equal half AT square plus UT. This is your equation number 2. Now we proceed for equation number 3. Equation number 3, we follow the same approach in as we follow in equation number 2. Now we take the again displacement. So displacement here is area of this. I will put the direct half into BD into BC plus OA into AB. So half BD as usual into T, BC represents V minus U, plus OA represents T, and that represents U. Now we can put the value of T from equation number 1. So value of T will be V minus U over A, and here V minus U plus V minus U over A into U. We have put the value of T in both parts. Now we observe V minus U over A is common. So now we can take V minus U over A as common, and we get inside the bracket V minus U over T plus U. We can solve this part by taking LCM 2. So therefore S equal V minus U over A, and we take the value LCM 2, and V minus U plus 2U. So V minus U over A and V plus U we can write over 2. Now there is an identity V minus U into V plus U. It can be written as V square minus U square over 2A, which equal S, and which gives equation number 3, means V square equal U square plus 2S. After cross multiplication you will get this value direct, V square equal U square plus 2S. This is our third equation of motion. So students, these are 3 equations, very important to understand the concept of motion. These are the equations written for uniformly accelerated motion, and it has been proved by simple graphical method. I hope it is clear to you. Thank you very much.